Hello, welcome to SMT Record. Today we are going to solve this LeetCode problem of July day 9. So the problem name is maximum weight of a binary tree. So if you read the problem statement, it's saying that you will be given one binary tree and you need to find the maximum weight. So maximum weight can be in any level, right? So suppose if you are considering this tree, right? So this is the first level. In the level 1 we have only one node, so that my weight is 1. But in the second level we have two nodes, 3 and 2. Then in this case my weight is 2. In the fourth level, in the third level we have 4 nodes, right? 5, 3, and there will be one null node here and the 9. So in this case our length is 4, right? So we are going to return 4 here and the label is 3. So that is the answer, right? So if you check this example, it's similar like the above one. In this case we have also the maximum node in the third level also, right? So in this case its length is 2. But in this case you check that we have maximum width in this second level only, not in the third, because in third level we have only one node. So in this case we are returning 2. But if you check this example, so if you check this example properly, you will get some more idea or give some more condition, right? So if you check that, if their explanation, if they are saying that maximum width is in the last, right, level 4, and the length is 8. Why 8? You can see that we have only two nodes, right, 6 and 7. But whenever you know that you have one leftmost node, in this case it's 6, and you have rightmost node 7, then you need to consider in between null nodes, right? So there should be one null node for 5, then again 5, like this do. And so in total we have 8. So in this case we are going to return the last one, right? Because you know the first leftmost node and you know the right leftmost node. In between you will have 6 null, right? So the length is 8. But in this scenario you can check that we don't have any rightmost nodes, right? So we are not considering null value. So if you know that you have a leftmost and a rightmost value, then only you need to consider null values, else you don't need to consider, right? So this is the explanation. So there are multiple ways to solve this. Today I am going to solve it using Java, and I am going to use the breadth-first search algorithm. So what I am going to do, since I am using breadth-first search, so I will traverse to each level of the tree, and I will try to find the width for each level, and I will return the maximum. So what I am going to do, I am going to traverse the first width, right? So 3 and 2. I am going to calculate the width for this particular level. Then again I will come here, and again I will calculate the width here. Then again I will calculate for 6, 7, and I need to consider null values also. Then again I am going to store that this is my width, and then I am going to return the max, right? So this is the logic I am going to follow. And let me write the code, and as and when needed I am going to explain it also, right, with example. So what I am going to do, so I told you that at first I need to check that my root is null or not. So if my root equals to null, then I am going to return 0, right? So we don't need to perform or any logic or something like that. So that will be my first step. Again, at this next step I am going to take one max value. In this I am going to store the maximum width. Okay, then since I am going to use the breadth-first search or BFL algorithm, so I am going to take the help of queue, and it should type with node. So you know that queue data structure, right? So in queue we used to store as fast in, fast out. So whatever element I am going to insert in the queue, that will be fast out, right? So let me name it as queue only, and I am going to use linked list. So I am going to use linked list implementation of the queue. Yeah, that's pretty much. Now, so if you check this, so there are two type of example, right? So I already told you need to keep track of the leftmost and rightmost to write our code for this kind of condition, right? So we need to track left and right, leftmost node and rightmost node. So let me take one variable. You can say leftmost, something like this, and I will initialize that 1. Then again I am going to take another variable. In that I am going to keep track of the rightmost. In this case I will initialize that 1 only. And if you check the example, so this intermediate value, this value has no use, right? So I am going to use that value with correct value. So since we are not doing anything with this value, I am going to use that value in other purpose. So we don't need this value, actual value, right? So what I am going to do, I am going to set in root equals to dot val equals to 1 for the root node. Okay, fine. So now what I am going to do, at first I am going to add the first element, right, in the queue, the root. So I will start from root. I will start my breadth-first search from root only, right? Until when I will continue until and unless my queue size is become 0, right? Whenever I know that my queue is empty, I'm not going to run anything. In that case, I'm going to return the max. Yeah, that's pretty much. Now let's write code inside our while loop. So here, what are we going to do? At first, I need to take the size, right? Since, let me write and then I will explain. So my size will be queue size, something like this. Yeah, so then what I'm going to do, I am going to take one for loop and I'm going to iterate through that loop, right? Or queue. So I will start from 0 and I less than size. I will explain you why I'm doing this, and I plus plus, fine. So next step, what I am going to do, I am going to check that my if I equals to 0 means I am considering the leftmost node, right? So if my I equals to 0, that means I am in the leftmost node, right? So I am going to update this leftmost variable with my current value, right? So it is 1 only, fine. And if my I equals to rightmost means size minus 1 in this case, then I am going to update my rightmost, right, with current root value. In this case, initially it will be 1 only for the first iteration. Now what I am going to do, I am going to check that we have left node or not. So if my left is not equals to null, then we can traverse further, right? In this case, what I am going to do, I am going to, okay, so before that I need to remove one number, right? So remove one node, the root node, then only we can iterate, right? So tree node equals to q dot remove. So what q dot remove do, it will remove the first node, whatever I inserted, since q works in first come first out, right? So whatever I inserted first, I will remove that first. And if I check, so let me name it as t here. Yeah, so if it should be t, and all these things should be t, right? So for the first time it will be root, but for other case it will be t only. Okay, fine. Now if I check that if t dot left it's not equal to null, then what I am going to do, I am going to assign one new value. So what will be my new value? 2 into whatever the current value in that, right? So my current value was t dot val, right? Yeah, I will explain it why I am doing this. Let me finish it first. Yeah, and if I need to check the same for my right node also, right child node, you can say. So t dot right dot val equals to 2 into t dot val plus 1. And what I need to do, I need to add that in my existing queue, right? So queue dot add t dot right. So at first I will update its value, then I am going to add it. Similarly, I need to do the same for this also. Q dot add t dot left, yeah, something like this. And whenever I am done with this, I am going to check my max value for each level, and I am going to take the max only. So I'm using inbuilt Java math function, so it should be max and rightmost minus leftmost then plus 1, right? So yeah, let me run the code, then I will explain the logic also. Yeah, you can see it's giving me expected answer. Let me submit also and check whether it's accepted or not. Yeah, it's accepted. Yeah, now let me explain my logic here. So at first what I have done here, I take one queue, right? So I take one queue, so queue will be first in first out, right? So what I am doing here, so this is my root node. So let's take this example, right? Okay, so this is my root node, and I have one here, right? So next what I am going to take, so I am taking the size for that, and in this case I have only one value, the leftmost value, so I am updating with 1 only initially. So and then Then what are we are doing? We are just doing for leftmost and rightmost to check the logic, right? After that, what we are doing, we are checking that if my left node is not null, so if it has child, then I am going to update its value using 2 into 2 dot value, right? So why we are doing this here? So let me open here also. Yeah. So if you represent any tree in an array, right? So if you, suppose I am representing it like this, so it is 1, then 3, then 2, then 5, then 3, then 9, right? So this is my array representation. So if you check, if it is your root node and if it start from 0, if we start from 1, if you think like that, then your left child will be in the second position, right? So, and again the right child will be third position. Again the left child of 3 will be in the fourth position, and the right child of 3 will be in the fifth position. So whenever you are calculating the value for the left node, I am going to multiply it with 2. And if I need to find the value for the right node, I am going to increment into 2 into n plus 1, right? The 2, 3. So in this case, my n is 1, and I need to calculate value for the left. So 2 into 1 equals 2, and for the right is 2 into 1 plus 1, right? That is 3. So this is the same thing we are doing it here, right? So we are doing it like we are setting the value. So if I check my left node is not null, then I am going to increment multiply that with 2. But if in the case of right node, we are going to multiply it 2, then we are increasing it by 1, right? Yeah. And another thing I need to explain here. So why we are taking this size q dot size again and again, right? Because whenever I am starting from here, right? So after the first iteration in my queue, so let me take one queue here, probably that will be easy to understand. So you can think this is my queue, right? So at first I am going to insert my root node. Then after iteration, I am going to insert my 2 child node, 2, 1, 3, right? So these 2, 3 and 2, you can say, and 3 and 2, these 2 nodes, right? So since I am doing breadth-first search again, so if I again go to the second loop, again I am going to remove the 3 and I am going to insert 5 and 5 like this, or you can say 5, 3 like this, right? So my size will be fixed. So I am initially my array before I am starting my for loop, my queue size will be 2, right? So that means I know whenever I am done with the size 2, that means I am done with that for that level. Then again I am recalculating the size. So again, whenever I am done with that, my queue will look like this, right? 5, I am considering this example. After iteration 2, my queue will like this, right? So again, I need to know this is my third level because I already removed the earlier one. So again, I will run my for loop for this 3 only. So that is the main reason. Yeah, that's the main logic what I am tried to perform here. So what we are doing here, at first we are taking one queue, and again after that we are taking 2 counter or 2 flag, you can say. In that we are inserting the value as a leftmost and rightmost. So why we are taking the leftmost or rightmost? Because in some scenario we need to consider the bit null values, right? In that scenario, for handling those scenarios, we are taking rightmost and leftmost, right? So to handle those scenarios, we are using leftmost and rightmost. So at first I took one queue, then I took 2 counter leftmost and rightmost. Then I started with the root node, I insert that in my queue. Then again I found the corresponding left and right child if exist. Then again I recalculate their value according to their position, 2 into n or 2 into n plus 1. Then whenever I am done with my first iteration or first level, I am going to recalculate the max value or max width. So let me explain another thing also in this scenario. So how this line occurs, right? So suppose this last line, I am saying about this last line. So how it's happened? So suppose in this scenario, right? So after this level, your width will be 2. But if you go into according to our given algorithm, after this level, you will not have any RM value, right? Your RM value will be the existing one. In this case, you will get negative value. So your max will become the earlier one. You will not find the new max. So that is the logic of max here. Yeah, that's pretty much for this video. If you like this video, to subscribe to our channel and share it with your friends. Thanks for watching. Bye bye.